I don't remember. Oh wow, very detailed. So now you mount this one. So I will just go through your notebook. Okay, so you are able to produce a summary, but do you know how to read this? You don't know, right? Remember, we'll go. Hmm. 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 There's actually another code that would produce a nicer table, but this one is good enough already. Oh, you managed to use backplot. Oh, smart. Huh? Did I? Oh, okay. Oh, okay. But do you know how to read this? Oh, that's something that we will go through today. Okay. Oh, you are able to produce. Why you didn't do this one on the data set? Why you didn't do this describe on your data, the Kaggle, the real data set? Oh, can. I will just have to refresh it. Ah, no, don't have. Uh, you see this one very troublesome, right? I have to print one by one. Value counts. Requirements for that question. No, just for you to explore only. Don't worry. So this is something that we'll go through today. So those, if you haven't done that, you can follow this one data set. I think all of you know how to import, right? So I don't have to go through that one. So let's go through what we are supposed to do this week. So this week we will be looking at one sample case study, which requires us to do regression. So it is a regression task. So this case study is about carbon dioxide emission of vehicles. So what we are trying to predict here is the carbon dioxide emission. What is the level of carbon dioxide emission from vehicles? Yeah. So now we take a look at our data set. So this data set consists of like car feature and the target variable that is continuous in nature. Okay. So then last week's lecture, we cover machine learning workflow and pipeline, right? What is the first machine learning step? Before that, problem statement. Problem statement. So how do we address problem statement? How to find? No, we can just see from the data set itself. Like say, for example, this case study is about carbon dioxide emission of car. So now our target variable is carbon dioxide emission. So how do we approach this problem is then we want to discuss what about this carbon dioxide. We want to say, okay, this carbon dioxide, they are greenhouse gas, they are contributing to global warming. This is a reason why we want to predict them. So this gives you a reason to predict carbon dioxide. So next, the question is, so this is the big introduction. So like when you study, when you have the first statement, right, you will also want to ask question like, okay, so now where does the additional carbon dioxide come from? Why does it get higher and higher and higher? So we know that factory produce a lot of carbon dioxide. Then some other farms also produce carbon dioxide, but car or vehicle on the road is also producing significant amount of carbon dioxide that causes the increase in level and therefore global warming. Okay, so that one is a big picture. So once you are good with the big picture, right? So then we want to ask again, in terms of problem statement, what we want to think about is the target variable and the feature that we are trying to do. So now say carbon dioxide emission, why can't we just put a sensor there and measure? Why do we want to take the trouble to predict? We have to ask this kind of question. Why are we even predicting it if, let's say, we can just put a sensor to trace, right? So whenever we think of this, we can think about three things. It's either about money, time, or governance. So say, for example, if you do this prediction, can you earn more money or can you save money? If you do this prediction, can you save time? Can you buy time before it happens? Then governance-wise is like, for example, if you predict this, can I do something about it to control certain thing? Say, for example, if this one is the case, right, we know that carbon dioxide is causing global warming, then can the government control the global warming within its city itself? Right? So answer is probably yes, if let's say this government start to impose some laws or tax on the family who emits beyond certain level of CO2. So say, for example, you will never know the CO2 in the air is contributed by who. But if you know how many cars a family have, you can estimate the level of CO2 that the family is trying to emit. So once, if let's say a family has 5 old cars, that gives out a lot of carbon dioxide to the air. So then the government can tax or to force these people to remove the old car, correct? So then they can control the level of CO2 from the big picture. This is something that you can think about. But it's okay if, let's say, we don't get to this point, but you will slowly get there. But essentially, why people are using this machine learning algorithm to do this task is because of 3 issues only: money, time, and governance. Yeah. If it doesn't involve money, time, and governance, nobody will spend the effort to do that. Okay? So that is about, so once we know that, we can sort of frame our problem statement and also the opportunity. Opportunity is in terms of, say, for example, we have a set of data, and then we know that nobody does anything about it. But we now have the knowledge of machine learning. We know we can do a regression model to predict so that the government can then use that to do certain things. So that one is the opportunity. Okay, we have the skill, we have the data set, now we can create something, we can do something. Okay, so that is one opportunity. So then once we form our opportunity, it will distill down to our goal, which is very, very simple and basic. That is, create a model to predict CO2 emission from vehicle based on vehicle characteristic. Like that, no? Okay, so this one is like for your assignment, the first part of the assignment: introduction, problem framing, opportunity, and also goal objectives. Okay, so then next one is the description of the data set that we have. So to describe the data set that we have, what we need is the source. The reason why we need to declare the source is always because we want to know how credible is this model. How reliable is this model? It depends on the source of the data. Okay, if the data come from government, we know that, okay, that definitely there is some legit methodology in terms of collecting them. So if, let's say, you just simply take it from online, probably people just replicate it and put it online, something like that. So that is the purpose of declaring the source. So then we also need to describe about how many rows are there, how many observations are there, and how many columns are there. So followed by that, we want to provide a metadata. Metadata is a table that describes the data set. It's a table that describes a data set. So what do we have to include in the metadata? So in the metadata, we must always put our columns attribute. So then a short description about the attribute and the sample data from the attribute. Okay, so this is called a metadata. So from this table, we can know that roughly what kind of feature are we trying to use to do a certain task. Okay, so that is on data set. Then it comes to, then only we come to EDA. Okay, so for EDA, The one who have already done, what is your feeling of doing EDA before we start this? It's very troublesome, right? No idea what are we doing. No idea what I'm trying to find. Okay, that is the exact thing that we want to cover today. So the EDA can be used in many tasks. Say, for example, there are certain tasks that requires you to explain the data pattern or whatsoever, what trend can you find? So those are very different. So in the context of machine learning, the EDA is very straightforward and very short. Yeah. So after this session, you will roughly have an estimate of how many pages of EDA you need. Essentially, it's very little. So what do we need to do for the EDA in machine learning context is 2 issue, 3 small things. The two issue is that we want to address from this EDA is find out whether there are any data issue. Second thing is find out which feature is good to train the model. So 2 things only. So on the first thing, right, we want to find out the data issue. That means we want to use some EDA to see whether there's any missing value or not. As simple as that. And we want to use some EDA technique to see whether there are any outlier, potential outlier. If there are, we need to remove it. If no, then we can just use them. Then finally is we want to use some plots to find out which feature is a good feature for training the model. 3 things. Very straightforward. Okay, so now whatever that we are covering today is very relevant and it's a set of I think what is essential for regression tasks, the essential EDA for regression. So yeah, so I think everyone, you guys are familiar with this one, right? You have tried already. So this is just about reading the data set. Then summary. Okay, so the first thing to do in EDA is always producing the data summary because we want to check the data quality first. Yeah, so we will use info bracket, info function to produce this output. So what do we read from here? So at the end of the day, what does this tell us is no missing value. When you read the data type, how would you read it? You have to read it side by side with this one, with a preview. Do you know how to preview the data frame? So to preview a data frame means after you read the data frame and save it in a variable, you just have to type the variable name and run the code. So if you run this, it will show you the first 5 rows of your data and the last 5 rows of your data. Yeah. So then when you read this data type, you can just compare with the input to see whether they are correct or not. Yeah. Then another thing is missing value. Make sure data type is correct. And check this one. So this line tells us that there are 8 numerical features, float and also integer, 5 categorical features. So 8 numerical feature means we need to produce 8 histograms to examine the frequency. That is very troublesome. So object 5 means we have 5 categorical columns. We can take a look at how they look like. Okay. So that one is the first thing. So first thing is we have already made sure that no missing value and no data issue. Okay, the key takeaway from here. So the finding, you have to describe a finding. Pasting this one, don't tell it doesn't show that you actually know how to read them. Okay. So then next one is statistical summary. So for statistical summary, what we can do is we have our DF ready. So we will say take this DF dot describe this DF. Okay, so once we do this df.describe, it will give us this summary table. You want to try reading this table? This describe will, the first thing that we need to make sure that there are 8 columns, because we know that there are 8 numerical columns. So 8 numerical column here, the first line tells us the total count. So how many observation has value? So we can see 10674 is the same for all the columns. Then we take a look at the mean. Mean is the average value. The next one is standard deviation. Then the next one is minimum value, maximum value, and the median value of the numerical column. Okay, so we take a look at the first one model here. If it tells us that the mean is 2014, the minimum is 2014, maximum 2014. What does it tell us? Only one value in that column. So then we know that this one is useless. So we drop this. So then engine size, we will see the mean and the median. So the mean says 3.3, the median says 3.4. So when the median and mean is close together, it means that they are probably normally distributed. They are not skewed. A skewed data will have the median and mean that is very far apart. Okay, so that's all we want to see. Then we want to make sure that the cylinder 5.7 versus 6 is also close. So they are probably normally distributed. The next one, 13.2 versus 12.6, probably normally distributed, even without seeing the histogram. Okay, so we want to check for all the columns here, including our target variable. Okay, so that's 2 things that we have already gotten from this table. Then the next thing that we want to check is checking the range of all the numerical column. Say, for example, we have altogether 8 features. We drop model year. We are not looking at target column now. So now we have 6 features that could be useful for us to train the model, correct? So in the case where we want to include all 6 features, we need to make sure that they are within the same range. So now we want to check, okay, this one, first one is around 3, the second one is 5, and then the biggest one here is about 26. So we know that they are roughly within the same range. But say, for example, if today you have one column which shows a value of 1,000 or 10,000, and the lowest is 3, we know that if we want to use the 2 column that is very extreme, we have to scale the value into a similar range. Otherwise, your model will just keep on focusing on reading the big values and forget the small one. Okay, that is from statistical summary for numerical column. Then the next one is how do we produce a statistical summary for the categorical column? So I saw you did it one by one, right? So in order to do that using this dot describe, we can also do that using this dot describe, except we have to create a small data frame which consists of only the categorical column. So say we need an additional step. So we say df, we select all the columns which are objects. We put into a small data set called data frame called dfcat. So from this dfcat we describe, it will produce this output. So this output tells us what? Similar to the previous one is the first row count. It tells us the count. You want to try on the rest? What is unique? Yeah. So like for example, Kame got 39 of them, unique value. The most frequently occurring one is Ford, and then it occurs 90 times out of 1,000 times. Then the next one is it has 600 unique values, and then the top occurring one is this, and then it occurs 8 times out of 1,000 times, so far and so forth. Okay, so like for example, when we see make from this preview, we can only see 2 types. But here it is telling us that, oh, there are actually 39 types in between the rows that we don't see. Yeah, altogether 39 rows. Okay, so from this table, what can we get out of this? Which one is useless? Comic is useless. Model is also useless. So for a regression task, if let's say the unique category is more than 5 to 10, we know that they are probably useless. Yeah, because we don't want to include too many categorical column in regression model. Yeah. As for classification, I think they are still fine. Okay. So now what we want to take note is we want to definitely drop model and also car make, and then vehicle class and transmission is something that we want to keep in view unless we notice something really interesting about the trend. So for field type, there are only 4 of them. We'll keep in view to see whether there's any trend that is related to field type. If there's no, then we can ignore. If there is any, then we'll include them. So yeah, so that's all on the summary. So as long as we have the 3 of the summaries, I think we are almost there already with the EDA for machine learning. So now we are left with the final task, which is to see which feature is good for our machine learning model. Okay, so now we will be using a pair plot. So for if you have done the task, if you plot the graph one by one, it is very, very tedious. So is there a shortcut? So this pair plot is a shortcut. Okay, it is a shortcut in plotting the histogram and also the scatter plot in just one line. Okay, so we will use the C1 package. Under the C1 package, there's a pair plot. So we'll just apply this pair plot on our data frame. So once we apply that, we are able to produce this very complicated chart. Okay, so what does this chart tell? It is a very, very busy chart. Do you have any idea which box do you have to read at a glance? Which one? This one. The boxes at the middle, at the diagonal middle, at the diagonal middle. So the boxes at the diagonal middle are all the histograms. Okay. So if we were to enlarge it, the first one is the histogram for engine size. For engine size, the label is on the left and at the bottom. Okay, so the next one is the histogram for cylinder. This is a histogram, right? Histogram should look like a bell curve. If a histogram looks like this, it's very weird, right? Shows that it is a discrete value. In the case where we want to use this column, we may want to treat them as categorical column or numerical column. Then there is a choice. This is what this chart suggests. Okay. So then the next one is fuel consumption in the city. We can see that it is a bell curve, also pretty normally distributed because we have already made sure that the mean and median are close. Then the next one is also similar, bell curve, bell curve, bell curve, and finally our target variable is also bell curve. Right? So that's all. But we mentioned that all those in the middle are supposed to be histogram. How about this one? Only one value, so that's why it looks very weird. So we know that this is useless. Okay. So then we are good with identifying the normal, the distribution already. That means we are quite set. The last one is still, the last task that we haven't resolved is selecting the feature. So selecting a feature for regression problem is very straightforward. We need to use scatter plot, right? We want to see which numerical feature describe our target variable best. Okay, so now from this pair plot, right, it has many pairs of scatter plot. It will explain the scatter plot between every single feature that we see. Yeah, So say, for example, this box over here, it is describing the relationship between the engine size and also the fuel consumption. But that's something that we do not need to know for machine learning context. For machine learning context, we only have to focus on the target row, on the relationship between the feature and the target. So we will only read everything at the final row here. So now here what it tells us is, the first one is the relationship between model year and carbon dioxide emission. We know that there's no trend, so that's not helpful. So for engine size, we see that the bigger it gets, the higher is the carbon dioxide emission, but they are quite scattered. But as in our model will only produce one line, right? So whenever it does a prediction, the prediction can be still far from the actual. Okay, so if in the case where you want to use this feature, we may want to combine it with other feature to create a multiple linear regression. Okay, so then cylinder is also establishing a trend, but they are very far apart. Okay, so fuel consumption city, they are also establishing a trend, a positive trend. Yeah, the higher it gets, the higher is the CO2 emission. This one is also similar, and this one is a reverse trend. The higher it gets, the lower is the carbon dioxide emission. So the bottom line from here, from this analysis is we know that, okay, all of the features except model year seems to be describing the target variable quite well. Seems to be describing the variance of the target variable quite well. Yeah. So then that's all. What does it tell us? Yes, correct. Yes, correct. That's all you want to know. Then there's another trend. If you are careful enough with the analysis, you will notice that 4 of these trends is very similar in a way that they are different from this one. Do you notice the white gap in between? Okay, so there's a white gap in between. It's unlike this one where, you know, there's no white gap one. Okay, so what does this white gap suggest? Like, for example, there are 3 lines. You can say that there is white gap or there are 3 lines. Okay, so these 3 lines tell us that, yes, we know that this fuel consumption in the city is affecting the carbon dioxide emission, but at the same time, there is another factor that is affecting this one, this trend. It could be a categorical feature because we know that it is very distinctive. How do we see that? Like, for example, when our consumption is about 20, we can see that certain vehicle is producing carbon dioxide in this level, but certain vehicle produce this level, right? So it is sort of like a categorical kind of thing. So if we see this trend, we should see how many trends are there. Like, for example, from here, right, it's about 2 to 3 trends. So if we know that there are 2 to 3 trends, then we go back to our categorical feature and find out to see whether there are any column that has more or less 2 to 3 category. If we see anything, that could be the one which is affecting the trend. So if we know that already, we can plot another pair plot to see, like, we hypothesize that it is because of the field type. So now we break it down by field type. So we have another pair plot that looks like this. So it becomes very clear that actually field type is the one that is affecting the trend like that. So if, let's say, a car with the consumption of this level, if it is a certain fuel type, it produces this level. But if it is another fuel type, it produces another level of CO2. That's what it means. Okay. So what it tells us is, okay, we know that we can use all these numerical features to make a good prediction model. But it would be better if, let's say, we add on another categorical feature, because the categorical feature defines a certain trend. But the thing is, regression model only takes in numerical feature. So the question is, how do we make them numerical? How do we make use of the categorical column? Okay, so in order to do that, we need to turn that column into number. And that technique is called feature engineering. Okay, so under feature engineering, there are many types. Some techniques allows us to transform the data into a certain range. So we won't be looking into that this time around. Yeah, we will be looking into feature encoding. So feature encoding is the one that allows us to encode the categorical variable into numbers. So there are two types. Two very commonly used ones. There are many types. So the commonly used one are one-hot encoding and also label encoding. So one-hot encoding will only use two numbers, 0 and 1. It's a binary. So label encoding is you can use a range of value to transform the column. The question is how and when. Okay, so for one-hot encoding, are you familiar with the concept? No. Okay, let's go through. So like for example, one-hot encoding is, say for example, we have a category that has 3 unique values, team A, team B, team C. But we only have 2 numbers to encode. That's not enough, right? Because we only got 0 and 1. We cannot have any other thing already. So the only way that we can do this is we break this down into the unique, we break this down into the columns that is relevant to its unique value. Say for example, team A, team B, team C like that. So from 1, we break them down into 3. If originally it says team A, we put a 1 under team A, 0, 0 under team B and C. Okay, so they are still same row, but just additional column. So then we can use 1 and 0. So if team B, then we say it's not team A, it is team B, it is not team C. So far and so forth. This is one-hot encoding. So for label encoding, it's very straightforward. So one team to one team. Say for example, if we see the first unique value, we put 0. Second unique value, we put 1. Then third unique value, we put 2. Like that. So if let's say we have 39, then we will have 0 until 39. Okay. So now the question is, when do we use which? Correct? So the situation where we use this label encoding is when we have a categorical column that has an ordinal rank, that we can rank the category. Say for example, if let's say we have a category that says risk, low risk, medium risk, high risk. So then this number will make sense to the category. In those situations, we can use label encoding. Yeah, like for example, education level, we can also rank them, right? So then label encoding can be used to encode those columns. Like severity also, we can encode them. Okay, months, we can also encode them. Okay, so in what situation do we then use one-hot encoding? Are the situation when we cannot rank the category. So anything that we cannot rank, we will use one-hot encoding. Say for example, color. We cannot rank them, right, by red, blue, green, yellow. So then in this situation, we need to encode them. Country of origin, we also cannot rank them. So then we will also use one-hot encoding. Okay, so then now back to our field type. Which one would you use? Label? One-hot? Why label? Why one-hot? The white gap, like the trend.
So I can see which field type is better. So by label that one, we can know this field type is what is field type being any certain level of symptom. So that is
Why do you think it's one-hot? Cannot rank. There's no ordinal ranking. Actually, there is no right or wrong answer. But I would personally prefer one-hot encoding. But your observation there, based on your observation, you should be choosing one-hot encoding. Because you mentioned that you want to create this gap, right? It's only by using one-hot encoding you can create this gap. Do you know why? You have the zero to zero the coefficient. So whenever it is a particular field, because our regression model is going to produce one line only. So if we one-hot encode it, we will have 3 coefficients for each of the field type. So then whenever the field type can only be tagged as 1 in any row, right? So whenever it is 1, it will take the coefficient that is relevant to that field type. Then if it is another field type, it will take the coefficient of another field type to move the line. If you use a label encoding, you only have 1 coefficient. But when it comes to another field type, which is accidentally coded as 3, it will give you a very funny value. So if you were to use the label encoding, you will see some points, predicted points, fall under this area. So next week, we will see the difference between one-hot encoding and also label encoding and see how will it affect the performance of the model. Okay, I think that's all for today. So now you got clearer context on the EDA for machine learning. As in, are you clear with what you should do? Better. Still not clear. Yes, and also to identify data issues. So other than that, we don't have to think about telling the stories. As long as we use the relevant technique to answer these few questions, that will do. Okay. Any other question? Accuracy, precision, recall, F1.
Small massa. It's like some literature you read as a
You just report the one that they report, but you can still choose.
but in our
But if you want to compare it to the literature, then you must include the one that they report.
so if some literature review didn't report, like example recall, then should I put that in the